Students, in this video, we are going to work through the volume of spheres. So we've looked at the volume of cylinders, and we've looked at the volume of cones. And those formulas are very similar. Volume of a cone is 1/3 the volume of a cylinder. But when we come to spheres, it's a little bit different. You'll notice what is absent from this formula is the height. So when we think about a sphere, I think most commonly we think of a basketball or a soccer ball, volleyball, something along those lines. We don't really have a height. We could certainly figure out how tall this is, but it would not be a height, it would be a diameter. And so everything is based off of the radius and its relationship to pi. Now, as I said in the cone video, we're not too much worried about, for pre-algebra purposes, where they got the 1/3 for cylinders, or cones, and where we're getting the 4/3 for the volume of a sphere. We're just going to ask you to trust us on that. So when I say we, I'm talking about myself and our textbook. I'm asking you to trust us that 4/3 pi r cubed, notice that's the difference here, we're actually going to have to cube the radius. Now when we think about that, we know that volume always deals in cubic units, cubic centimeters or cubic inches or cubic feet. And so in previous, like say with the volume of the cylinder, it is pi r squared times the height. So when you end up with r squared times the height, you end up with, say, centimeters squared times centimeters, which gives you centimeters cubed. This is volume. We must have a cubic unit for volume. And so when we come to the sphere, we no longer have that height. So we're going to have to work more extensively with the radius. And so here's your formula. 4/3 pi r cubed. Let's use this in some examples. And so in this first example, I have given you a radius of 6 millimeters. And so, as we've been doing, we know we're going to be doing some substitution and working through the math. So 4/3 pi r cubed, so that's going to be 6 millimeters cubed. Now, what can be tricky about these problems is, what do I do first? Well, remember PEMDAS. You're going to go parentheses first, then exponents, then do some multiplication and some division. So remember that. And so the easiest way to work through this is to simply say, and I think I did this in a previous video, let's put everything over 3. The 4 pi is going to be on the top, and the 6 millimeters cubed is going to be on the top. So let's go ahead and take care of that. That's 216 millimeters cubed. So you'll notice I have my cubic units. That's great. But I've got a 4 and a 3 that need to be dealt with. And so we're going to leave pi in our answer. So I'm going to multiply 216 by 4 and get 864 pi. That's all over 3. And now I'm going to divide by 3 and get 288 pi cubic millimeters. That is the volume of a sphere with a radius of 6 millimeters. Yes, you can multiply 288 by pi if you like. For our purposes, perfectly happy with you leaving pi in the answer. So what I want you to do is remember that formula. Volume equals 4/3 pi r cubed. Pause the video and try a couple of practice problems. Well, I hope you noticed something really odd about these practice problems. And obviously I was thinking cylinders and cones when I wrote these problems down. We don't need a height, do we? Because we are talking about the volume of a sphere in both of these problems. So hopefully you recognize that. That's not me trying to trick you. That's just me, well, not thinking clearly. Okay, so let's go back. Volume of a sphere, we know that the formula is 4/3 pi r cubed. And so, again, I think a good way to work these, let's put the 3 on the bottom. 4 pi r cubed, that's going to be 3 cubed, and that is 27. 27 in this case, cubic feet. And so then we want to multiply 27 by 4. And so if you're watching this closely, I'm trying my best to give you a framework for working these problems. Actually executing this math can be tricky. The substitution should not be tricky at this point. We've done a lot of that throughout the school year, but doing this math can be. So I want you to pay careful attention to how I'm working through these. It's very methodical, step by step, and that's what I encourage you to do. 108 divided by 3, in this case it does work out nice and even, 36 pi cubic feet. So again, we leave pi in our answer, and we get 36 pi cubic feet. Remember, to multiply the pi out is very simple. If you have a calculator, just do 36 times pi. And in this case, I will go ahead and give you that. 36 times pi, you will get approximately, now remember, it's an approximate answer at this point, 113.1 cubic feet if you want pi out of the answer. All right, let's move on to number 2. If you haven't done so already, pause the video and give it a shot. We know, again, I'm going to say this formula a lot because I want you to try to get it in your noggin. Volume of a sphere is 4/3 pi r cubed. Now, so we also know as we go back, we do not need the height, but this is also, that's a diameter. We talked about this in a previous video. These formulas are based off the radius, so I know that radius is 4 feet. So, as I rewrite this, that's going to be 4 pi times 4 cubed. All of that divided by 3. 4 cubed is 64. 64 times 4 is 256. So we've got 256 pi over 3, and that is going to be cubic feet. Now, if you divide 256 by 3, you get a decimal. You get a non-terminating decimal of 8.53 cubic feet. So this is really the best way to record the answer right there. Leave the 256 pi over 3. That is what we would call an exact answer. All right. This is an approximate answer. And you'll notice that I should have left pi in there. That is an approximate answer. All right. And so depending on what your homework or what your teacher is asking, at this point, if you're here, it's better to go ahead and multiply pi out. And you're going to further approximate the answer, but if that's what the directions are looking for, then do that. Typically, I don't really think you see much of 85.3 repeating pi. It's weird, isn't it? It's a little bit cumbersome. So again, this is your exact answer, but if you multiply 256 by 3 and then by pi, you're going to get an approximate answer. I believe we've got one more problem here, 2 more. And so again, I would encourage you to pause the video and go ahead and work through these. So now in number 3, we know we have volume of a sphere. Good to go ahead and write the formula down. Make sure we have it written down correctly. But you'll notice I give you a volume and I'm looking for the radius. And so now I have to substitute 200 cubic centimeters in for the volume, 4 pi r cubed, and put all of that over 3. And now the easiest way to solve this, in my opinion, is to multiply everything by 3. And so that's going to give me 600 cubic centimeters is equal to 4 pi r cubed. So at this point, the easiest thing to do, or really the only thing to do at this point, would be to divide both sides by 4 pi. Now this is where it might start looking a little bit messy. So when we do this, the 4 pi's will cancel, and we're left with r cubed on the right-hand side. And that's helpful because we know we're looking for r. 600 divided by 4 pi, however, gives you approximately 47.75. And that's, of course, is going to be centimeters cubed. Now, this is where your calculator becomes really handy, especially if you're moving towards like a TI-84 with a graphing calculator. I can show you in class how to keep all of those digits to the right, and so you can stop some of the unnecessary rounding. But for our purposes, rounding that long number to 47.75 is plenty good. But now remember, this is what's important. I see an r cubed because I'm working with volume, right? So I know I'm going to be dealing with cubic numbers. But if I'm searching for r, look at this. I'm not looking for r cubed. I'm looking for the radius. The radius is a linear measurement. It's not a volume or a capacity. It's not an area. It is a straight line distance. And so when we see this, we have to go back to earlier in the school year and say, oh, I need to take the cubed root. But what I do to one side, golden rule of algebra, I have to do to the other side. So when we think about a cube, a rough cube here real quick, we know a cube, a perfect cube, is 3, 3, and 3. Okay, so in this case, what would be the volume of this cube? Well, it would be 3 cubed, which is 27. Now, these numbers don't necessarily apply. I'm just trying to illustrate it. So if I were to take the cubed root of 27, what am I looking for? Well, the root is the side length, and it's a cube, so they're all the same. And so what I'm asking for in a cubed root is what number times itself 3 times? Well, that would be 3. Okay, and so that would apply here. What if I were to draw another cube real quick and just call it r? Okay, if I wanted to tack it to the radius. Well, the volume would be r times r times r, or r cubed. So the same thing would hold true. What if I take the cubed root of it? Well, I get back to r. All right, so when I take the cubed root, I get to r, but what is the cubed root of 47.75? Now, you're really only going to be able to do this if you've got a calculator. Yes, we can do it by hand, but it is quite laborious. If you take the cubed root of 47.75, it is approximately 3.6, but that would be centimeters because you're taking the cubed root of centimeters cubed as well. Now look, that's a lot. It's not easy, but it's also not that bad. You just got to walk through the process and remember all the concepts that we've learned this year in pre-algebra, because we've learned everything it takes to do this problem. We just have to put it all together. And what about solving for a hemisphere? This next problem, very straightforward here. A hemisphere would, I'm not going to be able to draw this very well, would look something like that, and that would be R. Think of the northern hemisphere of the planet, or southern hemisphere. We could think of eastern or western hemisphere. It is half a sphere. So you would solve for the volume of a sphere, and then you would divide that by 2. And so let's just make up let's use this problem here. It said the volume of that sphere is 200 cubic centimeters. So what would be the volume of the hemisphere? We would divide by 2. And the volume of the hemisphere would be 100 cubic centimeters. So whenever you see a problem involving a hemisphere, my advice, use the formula for the sphere, the volume of a sphere, 4/3 pi r cubed, and when you're done, or when you get to that point of the problem, divide that volume that you calculated by 2. And that is the easiest way to get to a hemisphere. It avoids you having to try and memorize another formula. Guys, I hope this helps. Please make sure you send me questions if you got them. Thanks.